today we'll solve exercise number 2.5 differentiation. Question number 10, part 7, cos inverse of 1 minus x square divided by 1 plus x square. So we'll solve this question. Let y is equal to cos inverse of 1 minus x square divided by 1 plus x square. So we can see that variable is x, so we'll differentiate with respect to x. D by dx y is equal to cos inverse of d by dx cos inverse of 1 minus x square divided by 1 plus x square. Basically derivative of cos inverse of this term. So as we know that derivative of cos inverse of x is equal to this minus 1 by under root 1 minus square minus 1 by under root 1 minus x square. So derivative of cos inverse of x, we can see that this term we consider as x. So d by dx is cos inverse of x is equal to minus 1 by under root 1 minus x square. X is this term and this square. Now we can see this is not simple x, so we'll differentiate 1 minus x square 1 plus x square. Further we simplify this minus 1 divided by under root 1 minus, we split whole square in the form of individually square and denominator in the individual square. Derivative of this time we can see that variable of two quotient variable. Derivative of two quotient variable, we consider this term as u and we consider this term as v. So derivative of u by v is v. V is 1 plus x square. Derivative of u, we consider u as 1 minus x square minus u is 1 minus x square. Derivative of v is we consider 1 plus x square whole divided by v square. V is 1 plus x square whole square. Now minus 1 by under root, we'll take LCM of these two terms. 1 plus x square whole square is LCM. 1 plus x square divided by 1, what it is 1 plus x square whole square is multiply 1, what we get 1 plus x square whole square minus this denominator divided by denominator, answer getting is multiplied by numerator. So 1 plus x square whole square is divided by 1 plus x square whole square, but we get 1 is multiplied by 1 minus x square as it is. Now 1 plus x square as it is. Derivative of 1 is constant and derivative of any constant is 0 minus as it is x square. Derivative of x square, here we apply power according to power rule and n is 2, x 2 minus 1 becomes 1. So derivative of minus x square is minus 2x minus 1 minus x square. Derivative of 1 is constant, so derivative of any constant is 0 plus derivative of x square and n is 2, x 2 minus 1 becomes 1. So 1 plus x square whole square as it is. Now minus 1 by, now we can see that this under will split 1 plus x whole square is equal to 1 plus 2x square plus x4 minus 1 minus x square whole square is equal to 1 minus 2x square plus x4, and also we will split this under root individually in the numerator and individually in the denominator. 1 plus x square whole square, this whole square and this 1 by 2 cancel, and 2x is common. What is left? Minus 1 plus x square and minus 1 minus x square divided by 1 plus x square whole square. Now what we get? Minus 1 by under root 1 plus 2x square plus x4 minus 1 plus 1 minus 1 minus into minus plus 2x square minus plus minus x4 whole divided by 1 plus x square. Now 2x minus into 1 minus 1 minus plus minus x square minus plus minus 1 minus plus x square divided by 1 plus square whole square. Now minus x square plus x square cancel, 1 plus x square and this 2 cancel, plus 1 and plus x4 minus x4 cancel. What is left? 2x square plus 2x square, 4x square under root 4x square minus 1 by under root 4x square, and minus 2 1 minus 1 minus plus sign minus 2 into 2x and divided by 1 plus x square is left. So what we write? dy by dx is equal to minus 1 by under root 4x square and 2x into minus 2 divided by 1 plus square. We can see that this term is cancelled by this, and plus x square minus x square cancel. This is minus 2 and into 2x and minus 1 divided by under root 4x square. Under root 4x square. So now dy by dx is equal to minus plus 2 to the 4x divided by under 2x becomes 2x 1 plus x square. 2 and 2 1 are 2 to the 4x and it's cancelled. 2 by 1 plus x square dy by dx. So derivative of cos inverse of 1 minus x square divided by 1 plus x square is equal to 2 by 1 plus x square, which is our required solution.